In the question, they are saying that there is a ball which is bouncing between the railway compartments, and it is bouncing such a that it is elastically bouncing. What the elastically bouncing mean? Elastically bouncing means the when the ball it starts from its motion, when it collides with the opposite compartment wall of the compartment, then its a collision is such a way that it is colliding elastically. That is, during the collision, its momentum and kinetic energy both are conserved. So overall, when the ball is moving with a 1 meter per second velocity, actually after collision, its velocity magnitude is same, but only the direction is reversed. So this is meant by the bouncing elastically indirectly. Okay. Next, it is moving with a 1 meter per second velocity between the walls of the railway compartment of size 10 meters. Okay, and it is moving in the direction perpendicular to the walls. Here walls are in this direction and the motion of the ball is in this direction, so it is moving perpendicularly. Okay, now another, the train is moving at a constant speed. Now this train is moving with a constant speed, that is 10 meters per second, and the direction of motion of train is parallel to the direction of motion of the ball. See, the ball will move either in the right direction or in the left direction due to collisions. Okay, so in the overall journey, the direction of motion of train is always parallel to the direction of motion of ball. So, as seen from the ground, they are saying that as seen from the ground. So, it plays most important. If you won't consider this statement, if you neglect this, then everything will be obtained will be wrong. So, what are the values we are finding in the options? They all are with respect to the person standing on the ground, as seen from the ground. Okay, as seen from the ground. So now option A, let us verify the option A. Option A says that the direction of motion of the ball changes for every 10 seconds. Okay, direction of motion of the ball changes for every 10 seconds. So what does that direction of motion mean? It is actually the velocity direction. So velocity we have already seen, the velocity is always directed in the direction of motion. So indirectly they have provided the velocity direction. Okay, so they are saying that the direction of motion of the ball changes for every 10 seconds. So we have as seen from the ground, we have to attach this as seen from the ground, the direction of motion of the ball changes for every 10 seconds. So we have to verify whether with respect to the person standing on the ground, whether he observes any change in the direction of motion of the ball or not. So when the person standing on the ground, when he observes this ball, actually the ball when it was moving with 1 meter per second velocity in the right direction, and the train was moving with 10 meters per second velocity, then with respect to the person standing on the ground, velocity of ball with respect to the person standing on the ground, it becomes velocity of ball with respect to train plus velocity of train with respect to ground, which means that it is both are in the same direction and both are directed in the positive direction. So 1 plus 1 meters per second plus 10 meters per second, so you'll obtain that 11 meters per second. When it means at the first instant when the ball was moving in the rightward direction, that is in the direction of motion of the train, with respect to the person standing in the ground, the velocity of ball with respect to the person standing on the ground, he observed that the ball is moving with 11 meters per second velocity in the right direction. In the second scenario, what happens in the second scenario? After some time, the ball will reach to the opposite wall of the compartment and it will bounces back elastically. That is, its velocity will remain same, only the direction gets reversed. But so here it is now the ball is moving in the opposite direction of the motion of the train, that is 10 meters per second. So, when the person standing on the ground, when he observes here this scenario, he will observe that with respect to the person standing on the ground, velocity of ball with respect to the person standing on the ground becomes velocity of ball with respect to train plus velocity of train with respect to ground. So here, velocity of ball with respect to train is now in the leftward direction, so it will be minus 1 meter per second plus 10 meters per second. Overall velocity is plus 9 meters per second. That is nothing but with respect to the person standing on the ground, he observes that though actually the ball is moving in the left direction with respect to the person standing inside the ground, but the observer standing outside the train or on the ground, he will observe that the ball is moving in the rightward direction with 9 meters per second velocity. So in the so again once again, after when the ball it reaches here, again when it collides and bounces back, the same scenario will occur. Okay, the same case will occur, the same scenario will occur. Means the in the overall motion with respect to the person standing on the ground, you will observe that the ball velocity is switching to 11 meters per second to 9 meters per second and 9 to 11 and so on. So in the overall motion, you will observe that there is no change. Who is observing all this with respect to the person standing on the ground? You will observe that there is no change in the direction of motion. That is, there is no change in the direction of motion. There is no change in the direction of velocity of the ball. So option A, the direction of motion of the ball changes for every 10 seconds is wrong, because in the whole journey with respect to the person standing on the ground as seen from the ground, the direction of motion of the ball is not changing at all. Now moving to the option B. Option B says that the speed of the ball changes for every 10 seconds. So, in order to understand the option B, first you should be familiar what is the speed. So, what is the speed here? Speed is actually nothing but it is the magnitude of velocity, right? So, with as seen from the ground, again we have to attach this as seen from the ground with as seen from the ground. The speed of the ball changes for every 10 seconds. So, we know that in the previous scenario we know that the direction of velocity was not changing with respect to the person standing on the ground. It was always directed in the rightward direction, but we have seen that the magnitude of velocity with respect to the person standing on the ground was changed to level to 9. Means there is obviously there is a change in the speed. That is nothing but there is a change in the magnitude of velocity. Okay, so now we have to find that what time was required for the ball to change its velocity from 11 meters per second to 9 meters per second with respect to the person standing on the ground. So in order to understand this, first we have to understand why the ball velocity with respect to the person standing in the ground, why the velocity changed to 9 meters per second. Why? What was the reason the ball has changed its velocity to 9 meters per second? Because the ball was bounced back. So wow, we need to find that the how much time the ball took to bounce the ball. So when we find this time, then we can indirectly find that the time required for the ball to change its velocity from 11 meters per second to 9 meters per second. So we need to find the time in what time the ball bounced back. Means in what time the time required for the ball to collide with the wall. So the time required for the ball to collide with the ball is nothing but when the ball will collide with the ball when it travels the 10 meters of distance. So now in the overall we need to find the time. So that time is nothing but distance by speed. Here the distance of the compartment is 10 meters. The distance between the walls of the compartment is 10 meters and the velocity or the speed of the ball is 1 meter per second. So time the so after 10 seconds it means that when the ball was moving with the 11 meters per second velocity, after 10 seconds its velocity with respect to the person standing on the ground became 9 meters per second. Means its speed was changed. Okay, its speed was changed after 10 seconds and this process repeats further. So every after every 10 seconds the speed of the ball will change. So option B is also true. Now coming to option C. Option C says that the average speed of as seen from the ground, the average speed of the ball. As seen from the ground, the average speed of the ball over the fixed time interval is fixed. Over the 20 seconds time interval is fixed. So now to check the option C, as seen from the ground, they are asking the average speed with respect to the person standing on the ground. Whose average speed they are asking? Average speed of the ball with respect to the person standing on the ground. So what is the formula of average speed? It is the total distance traveled. Okay, total distance traveled by the ball with respect to the person standing on the ground by total time interval. So delta t. So here again the total distance traveled by the ball with respect to the person standing on the ground So when the person standing on the ground observes the motion of the train, so actually the train is moving at 10 meters per second velocity, and after 20 seconds the train has moved the distance of the train has moved the distance of, that is nothing but speed into time. Speed of the train is nothing but 10 meters per second into time is 20 seconds. So in the 20 seconds the train has moved 200 meters distance. With respect to the person standing on the ground, the train had moved 200 meters distance in 20 seconds. So he will observe that the ball is inside the train, so it has also moved the 200 meters distance in 20 seconds. So when we put the values here, the total distance traveled by the ball with respect to the person standing on the ground is again 200 meters by the time over the time interval 20 seconds. So we get the 10 meters per second. Means the average speed of the ball is again a fixed value, that is a constant value 10 meters per second. So we can say that the average speed of the ball over the 20 seconds time interval is fixed. Option C is true. Coming to the option D, the acceleration of ball is same as from the train. We won't understand this if you won't attach the above as seen from the ground. So we have to attach that as seen from the ground. The acceleration of the ball, as seen from the ground, the acceleration of ball is same as from the train. So first, let us write it in the formula form so that we'll be able to understand very clear. As seen from the ground. Okay. So now here, as seen from the ground, the acceleration of ball. As seen from the ground, the acceleration of ball, it means the acceleration of ball with respect to ground is the same as the acceleration from the train. Means it is equals to the acceleration of ball with respect to train. So we have to check whether the acceleration of ball with respect to ground is equals to the acceleration of ball with respect to train or not. So first, acceleration of ball with respect to ground. So in the above, we have seen that with respect to the person standing in the ground, the ball was actually moving with 11 meters per second velocity, and after 10 seconds, okay, the velocity of the ball was changed to 9 meters per second velocity. So here the acceleration of this ball with respect to the person standing on the ground becomes V final minus V initial by T. So here V final is 9 meters per second minus 11 meters per second by time taken between them was 10. So overall it is minus 2 by 10, that is nothing but minus 1 by 5 meter per second square. So it is the acceleration of the ball with respect to ground. Now, acceleration of ball with respect to train. In order to understand this, first, okay. So, acceleration of ball with respect to train. So, when the ball was moving with a velocity 1 meter per second, we have to assume ourselves as we are a compartment of the train. So when you assume yourself as a compartment, as in the wall of a compartment in the train, then you will see that the ball is moving with the velocity of ball with respect to train becomes 10 meters per second plus 1 meter per second, that is nothing but minus 9 meters per second. In the first scenario, when the ball actually was moving in the right direction with 1 meter per second, in that case the velocity of ball with respect to train becomes minus 9 meters per second. So in the second scenario, when the ball collides with the wall of the compartment and it bounces back, then the velocity of the ball is 1 meter per second in the left direction, and the same direction the 10 meter per second velocity of train. Okay, so velocity of ball with respect to train here becomes minus 10 meters per second minus 1 meter per second. So overall it is minus 11 meters per second, and the overall change was happened, the time taken for the ball to collide with the compartment wall of the compartment was 10 seconds. So this change in velocity was occurred after time interval 10 seconds. So acceleration of ball with respect to train is now final velocity is minus level. So minus level minus of initial velocity is minus 9. So v final minus v initial by time is 10 seconds. So minus level plus 9 by 10. So again we will get minus 1 by 5 meter per second square. So we can observe that acceleration of ball with respect to train and acceleration of ball with respect to ground both are equal. So option D is also true.